Okay, today we're going to do a video on the connected at sea Wi-Fi hotspot. So this will send your NMEA 0183 signal over Wi-Fi, and it creates a Wi-Fi hotspot for you to log on to. Just 4 wires, 2 signal wires, and your power and ground. Along with the kit would come a DC to DC step-down voltage regulator, so that will take your bus power from your bus bar or your battery down from 12 volts to the required 5 volts for the electronics, and just a simple 1 amp fuse. Okay, so the first thing we're going to do is mocked up this scenario here. It would be typical installation through the deck of a boat. So this can be mounted anywhere, inside, outside. It's completely waterproof. Always remember, line of sight is best. So we'll start out with just a 1/2 inch hole and 2 small auxiliary holes for the Phillips screws. Okay, there we go. I will just mount this here. Okay. Okay, so in this scenario, I'm just going to hook up the power and ground to some terminal studs for ease of demonstration. Normally, in the real-world installation, you will be soldering these connectors together. Okay, so the next thing I'm going to do is I'm going to check if we've got some voltage at our bus bar here. Okay, so I got 11.85 volts. That would be indicative of a car battery with about 1/4 of its charge left. The next thing I'm going to do is put in my circuit protection. And I'm going to install the DC to DC step-down voltage regulator. So these wires can be attached directly to your battery, or in this scenario, your bus bar. So ground to ground and power to the fused side. And next we will hook up the power and ground to the Wi-Fi hotspot. So if the voltage regulator is doing its job, we should see right around 5 volts on on these terminal studs. And there we go, 5.01, so that's perfect. Now that we have the power hooked up, we can just check on a phone here, go to Wi-Fi, turn it on and off, and see if we get the network SSID connected at sea. There we go. So we have created a hotspot. Clearly won't be able to receive any data on this because we don't have our signal wires hooked up at this point. So the NMEA 0183 standard uses what's called the RS-422 protocol. It uses two wires to transmit as if it would use two wires to receive. So it's called a differential signal. It sends a low voltage signal, what's called a TTL level signal, 0 to 5 volt on one line, and it sends the opposite, the inverse, on the other line. So when it's sending 5 volts on one line, it'll send 0 on the other, and vice versa. So it creates very little electrical noise. That's also combined with the twisted pair configuration, which has incidentally been around since 1881 when Alexander Graham Bell patented it. And the TTL level uses 0 to 5 volts. So the combination of all these things create a very low electromagnetic interference environment, so you can transmit using RS-422 wiring like this a great distance, 1,000 feet, no problem. So it's a fantastic wiring system to use. So here I have a twisted pair. This is coming out of a GPS. So oftentimes manufacturers will name them as here NMEA A wire and B wire, and here it'll be data plus and data minus. And said depending on the manufacturer, the data plus might be minus, and so on and so forth. So essentially you have a 50-50 chance if you don't know what the wires are. So if you see a set of wires coming out that just happen to say NMEA out, when you put them in and it's not signaling, you just reverse the wires. You can't short it out. There's really no problem with hooking this up. So I'm just going to use an electronics fuse block here, and just insert in the screw terminals my NMEA A wire and my NMEA B wire, and I will do the same here. Get my NMEA A wire, data plus in this case, and we'll get the NMEA data minus wire. Okay, so one of the easiest sources of wire for the twisted pair is in just your relatively inexpensive, say, Cat5 cable. So I just removed the RJ45 end off here, and inside of a Cat5 cable you'll see 4 sets of twisted pairs. So you can use any one of these pairs to transmit or receive. Ideally, you would want a jacket that is insulated. This one isn't, and even better if you can find one with individually wrapped twisted pair. In this scenario, we're only going a very short distance, so it's not going to matter, but when you're looking at them, that's what you want. So these are 22 gauge wires. I think that's what the standard calls for. And if I just, another thing to look for, if I just strip off if I just strip off a bit of this wire, I'm looking for strands like this. The Cat5 comes in solid core 2, which will break much easier if you're running it around corners. So look for stranded wire, 22 gauge, shielded individually if possible, and or shielded in a jacket, and that will. They say you can send them so far that you'll run out of cable before you run out of transmission distance. Okay, so now I'm going to just switch over to OpenCPN and finish up the rest of the installation.